Hello friends, welcome to my YouTube channel. In this course, we will learn machine learning from basics to advanced. Our first module is Introduction to Machine Learning. So let's get it started. Have you ever wondered how Netflix knows what movies you will like or how your phone unlocks just by looking at your face? The answer lies in machine learning. Whether it's predicting your next favorite song or recommending the quickest route home, machine learning is changing the world, and today you are going to learn exactly how. Machine learning is a subset of artificial intelligence that allows computer to learn from data without being explicitly programmed. Think of it like teaching a computer to recognize patterns or make decisions based on historical data without writing detailed instructions for every possible outcome. Machine learning uses algorithm to deduct patterns in data. The more data a machine learning model is exposed to, the better it performs. Sounds difficult? Let's take an example. Spam email detection is a crucial application of machine learning. The goal is to classify incoming emails as either spam or not spam. This helps to filter out unwanted emails and keep your inbox organized. It starts with a data set containing thousands of emails that have been labeled as either spam or not spam. These emails serve as examples for the machine learning model to learn from. Machine learning analyzes patterns between spam and non-spam by detecting some key features, keywords which are more likely to appear in spam emails such as free, win, etc. Moreover, spam emails also have strange formatting like excessive capital letters and multiple exclamation marks. Spam often comes from suspicious or unverified email addresses, so ML can analyze the domain and sender reputation and learn these patterns to differentiate between spam and non-spam. Once machine learning model is trained on the labeled dataset, the final model can now make predictions on new dataset way of email that it hasn't seen before. In this manner, ML model efficiency is evaluated, and over time, machine learning become more effective by continuously learning. Machine learning is often confused with AI and deep learning. So let's see the difference between these three domains. AI is a broad concept where machine mimic human intelligence, for example, playing chess or solving problems, whereas machine learning is a subset of AI that focuses on learning from data. Deep learning, whereas, is a further subset of machine learning that uses neural networks with many layers, hence deep, to solve highly complex problems like facial recognition. Machine learning has become more essential in today's technology driven world. It covered almost all the fields of engineering and sciences, and it can be used for pattern recognition and and for the predictions of the future. In healthcare, it predicted diseases from medical images like x-rays. In finance sector, it play crucial role by detecting fraudulent transactions automatically. Voice assistants like Siri and Alexa can understand speech and provide intelligent responses. We are living in self-driving cars era. Machine learning enable these cars to understand road signs and driving conditions. These examples show how machine learning is revolutionizing industries, making our life easier, faster, and more efficient. So first let's talk about the volume of data we are dealing with. It's not just increasing, it's skyrocketing. Every year the amount of data produced is several times greater than the year before. Think about it, from social media posts, online transactions to sensor data from smart devices, our digital footprint is growing exponentially. Now, here's the kicker. Despite this massive influx of data, humans can only process a tiny fraction of it. Just imagine if you had to read and analyze every single email, tweet, and transactions that's generated every second. It's simply impossible. Here is another interesting point. While data is cheap and abundant, almost like a free-flowing river, knowledge is rare and costly. The sheer volume of data we have is no longer the problem. The challenge lies in turning that data into actionable insights. So, what's the solution? Knowledge discovery is key. This process involves extracting meaningful insights from raw data, transforming it into valuable information we can use to make informed decisions. It's like finding hidden treasure in a vast sea. Now, look at the evolution of machine learning. It is not something that just appeared overnight. It has evolved over decades, and its growth is fueled by advances in computing power and the massive amount of data generated today. Let's look into brief timeline. In the 1950s, Alan Turing asked a groundbreaking question: can machine think? This question laid the foundation for AI. Fast forward of the 1990s, the advent of the internet dramatically increased the availability of massive datasets which were crucial for machine learning. By the 2000s and continuing into the present, the field of machine learning and AI experienced explosive growth. This surge was driven by the combination of big data and the power of cloud computing, allowing machines to learn from vast amounts of information and perform complex tasks with unprecedented efficiency. The key breakthrough of the evolution is deep learning and reinforcement learning. Deep learning is a part of machine learning where models are designed like the human brain to solve more complex problems like image and speech recognition. In reinforcement learning, machines learn from their mistakes by receiving feedback from their environment. So there are three main types of machine learning: supervised, unsupervised reinforcement learning. Regression and classification are subcategories of supervised learning, and clustering is a category of unsupervised learning. In this videos, we will only look at the overview of these three types, and we will discuss the regression, classification, and clustering in detail in our upcoming videos. Supervised learning is the most common form of machine learning. In this type of learning, the model is trained on labeled data where the correct answers are provided. It learns to map inputs to output and generalize for unseen data. Regression, classification, and multi-class classification are its applications. So let's look into example of supervised learning. Suppose we have a labeled dataset of cat and dog's images. ML model is trained on this data and learn the features of the dog and cat. Then unseen data is given to that trained model and it will predict whether the image is cat and dog. This is how supervised learning works. In unsupervised learning, the algorithm works with data that doesn't come with labels or predefined categories. Instead of being told what each piece of data represents, the algorithm has to figure things out on its own. For example, if you have a bunch of images of animals, the algorithm will look at features like size, shape, fur, pattern, and color. It then tries to group these images into cluster of animals that share similar characteristics. This approach involves techniques like clustering, where the algorithm groups data points that are close to each other, and density estimation, which helps in understanding the distribution of data across different areas. Let's focus on an example of unsupervised learning with just animals. Imagine you have a data set of various animal images. For example, here are cats, camel, pandas, but no labels that tell the model which animal is which. The machine learning algorithm analyzes the feature of each image, and based on these features, it will group these animals into with that share similar characteristics. So output will be three clusters where cats, camels, and pandas are grouped separately based on their features. Reinforcement learning is a type of machine learning where an agent learns by interacting with its environment and receive awards or penalties. Consider an example of training a dog to sit on command. Here, dog will be the agent, living room will be our environment. Dog can perform four actions: sit, stand, bark, or jump. There can be two states, either dog is standing or sitting. Reward will be a bone when dog is sit on command. So initially the dog might not know what sit means and could randomly try different actions like jumping or barking. Over time the dog learns that sitting on commands leads to a treat. The dog reinforces the correct action because it wants the reward. After several training sessions, the dog learns to sit when it hears the command as it associates this action with the reward. In summary, machine learning empowers systems to learn from data, adapt over time, and make intelligent decisions, transforming how we solve complex problems and drive innovative solutions across industries. In this video, we have seen basics of machine learning process, differentiate between AI, ML, and DL, importance of machine learning, evolution of machine learning, supervised, unsupervised, and reinforcement learning. In the next video, we will explore the different types of machine learning in detail and take a closer look at real life examples. You will also get hands on as we get start coding simple models. So don't miss it. If you found this lecture helpful, make sure to like, share, and subscribe. Let's embark on this machine learning journey together.